Hello everyone, welcome back to another video lesson, and this time we're going to go over the lesson on angles of elevation and depression. So what I'm going to ask you to do is go ahead and pause the video, copy all of this down, and once you're done copying this down, then you can press play again and start copying what's going to come next on this section. Okay. So, term description, an angle of elevation is the angle formed by a horizontal line and the line of sight to an object above the horizontal line. Notice that I underline above, okay? And an angle of depression is all of this, but instead of above, it's going to be below. So just to give you an idea of what this is saying, I'm going to draw a diagram. So let's say we have a hot air balloon. Okay, and I'm not an artist, but I'll try my best to give you a nice picture here. So we have this hot air balloon, and there's this person here inside the basket. Okay, uh, and then we have this is the ground, and let's say we have someone here looking up to the hot air balloon. So what this is saying is you have this horizontal line, okay, and then this is how the angle of depression is going to get formed. So this one here will be the angle of depression, this angle here. Okay, and this one will be the angle of elevation. So think of it this way. If you're the person inside of this hot air balloon and you're looking down, okay, see this will be your angle of depression. And what if you're this person looking up to the hot air balloon? Then your side with this horizontal line is going to form the angle of elevation. Okay, I'm going to scroll this up a little bit so you can see what's going to come next. So this will be the first example, and the challenge here is going to be that we have word problems. Okay, so go ahead and copy this down, and then once you're done, pause the video, copy that down, and then press play again so you can see how we can work this problem out. Okay. Okay, so let's read this problem to see if we can get the important information from all of these words. Okay, so this is a worker is in a building 400 feet away from a wind turbine. The angle of elevation to the top of the wind turbine is 35.5 degrees. The question is approximately how tall is the wind turbine? So as you can see, this is just a bunch of words, and we need to get the information out of all of these words and then draw a diagram to help us visualize or help our brain visualize what we're supposed to do. So I see 400 feet, okay, so that's key. And then I also see the angle. Let's see the angle. It's an angle of elevation, and it says that it has a measure of 35.5 degrees. And the question is, how tall is the wind turbine? So that's what we need to answer. So again, to help my brain help me figure this out, what I'm going to do is I'm going to draw a diagram. So let's say I'm not an artist again, but I think I can assume or say that this is a house here. Okay, so assume that this is a house. Okay, that's a house. And assume that this house has a triangular roof or triangular shaped roof. And let's say this is the worker. Okay, so that's the worker. And then somewhere here we have the wind turbine. So let's see. Okay. And I went over here. That's fine. Okay, so we have this distance, and I'm going to cover this because it freaks me out if I just leave it like that. All right, so it says that from here, okay, so if we just draw so that this line so we can form a triangle, okay, this angle has a 35.5 degree measure, okay. So there's the angle, and then we're also told that the worker is in a building that is 400 feet away, so that means that this is 400 feet. So from here to the wind turbine, 400 feet, and what they want us to find is the height of the wind turbine. So this will be x, what we don't know. Now, let's remember our mnemonic for trigonometric functions. So we know sine is opposite over hypotenuse, so there's the soft part. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, SOHCAHTOA. All right, so based on the angle here, this is the angle of reference. This side is opposite to the angle, so that makes it the opposite side. And then this side is adjacent to the angle or right next to the angle, which means this is A, okay? So now we have opposite and adjacent. So let's look at this, and we see that the one that has opposite and adjacent is the tangent one. So then I'm going to write down tangent. The angle is 35.5, and tangent is equal to opposite is x, and adjacent is 400. Okay, so then so we can solve this as a proportion. I'm going to write a 1 under the tangent of 35.5, and then I'm going to cross multiply. So when I cross multiply, 1 times x is going to give me x by itself, which is what I wanted, and then this will give me 400 tangent of 35.5. Now, once I get to this part, I'm going to enter this on my phone calculator, and that's going to give me the answer to this problem. So once you do that, this gives you approximately 285.3 feet. Okay, so that will be the answer to this problem. Let's continue. Okay, so let's go to the second example, and this will be the last example in this video lesson. Okay, so pause the video, copy this on your paper, on your notebook, and then once you're done copying it down, you can press play. Okay, so now that you have this written down in your paper, let's see. Again, we have a bunch of words, and we need to get the important information out of all of these words here. So to approach a runway of the airport, a pilot must begin at a 3-degree angle. Okay, so that's going to be important. Starting from a height of 2,714 feet. So that's going to be important. Above sea level. The airport is 1,007 feet above sea level, so we know this is going to be useful also. To the nearest tenth of a mile, how far from the runway is the airplane in a straight line? Okay, so again, a bunch of words, and we just need to pull out the important information from here. So the challenge is this: you see words and you right away might feel intimidated, but again, just underline what's important, and then we'll begin to figure out the problem. So first of all, again, to give my brain some help, as to how I need to go or approach this problem, I'm going to draw a diagram. So again, I'm going to draw an airplane. Okay, so let's say this is an airplane. And again, I'm not an artist, so if you can draw better than me, that's fine. So let's say that's the airplane. Okay, so and let's say this is the airport here. Okay, so let's say that's the airport, and it says that the airport is 1,007 feet above sea level, and the airplane is 2,714 feet above sea level. Okay, so let's continue with the diagram, and then we'll come back to that information in a moment. So if I draw, let's see, if I draw this side, and this will be the horizontal, okay, line of sight. Okay, and as we know, airplanes don't go in this direction then down and then down. They actually go down just like this. Okay, when they land. So once you have the diagram, then we'll go back to this one. Okay, this is 2,714 feet, and this is 1,007 feet above sea level. Now there's a trick here. Okay, so what I need to do is I need to subtract this distance from that distance, because they're both above sea level. Okay, so let's say this is sea level here. So this will be the airport. Let's just so that you get this idea here. So this is 1,007, and this distance here is we're given 2,714 feet. Okay, so what I'm going to do is I'm just interested in this distance. Okay, that distance there. Okay, so this is what we need to so what we do is I'm going to subtract this distance from this distance. So if I subtract 2,714, if I subtract 1,007 from 2,714, I'm left with 1,707. Okay, so this means that this distance from here to here is 1,707 feet. And what they want us to find is, what if this airplane was able to go down in a straight line, which airplanes are able to. Okay, so this will be x. So now the angle, this angle, they're saying that is 3 degrees. And again, I know this does not look like a 3-degree angle, but we're just trying to get an idea as to how we need to work this problem out. So based on this angle of reference, this side is going to be the opposite, and we know that this one here is the, okay, it's the hypotenuse. So we have O and H, which means, going back to this one here, we use sine. So then the setup is sine of the angle is 3 degrees, is equal to opposite over hypotenuse. So the opposite is 1,707, and the hypotenuse is what we don't know. And again, write a 1 so we can work this out as a proportion. So then we have x sine of 3 equals, let's see, so this will be 1,707, and then divide by sine of 3. And when you enter this in your calculator, it's going to give you approximately 32,616.2. Okay, I paused the video as I was recording, and I just wrote this down, okay, because I don't want to make this video too long. So what I did is I wrote that 1 mile is equal to 5,280 feet. And notice that this answer is in feet, okay? But the question is saying it's asking you to do it in miles. So that means we need to convert. So to convert feet to miles, we use this. So this is 32,616.2 feet. We divide that by 5280, and what the result you get out of this is 6.2 miles. So this will be the answer to that problem. Okay, and I apologize for making this video too long. I'll talk to you guys on the next video lesson. Bye.